Finally is the concept that data has value, right? So you're seeing, whether it's long-tail business models to, companies who book data as an asset of their business, to companies who build their entire business around data, or an application, as we'll see, around data. And so often when people talk about big data, they'll say, oh, it's the 3 V's, velocity, variety. Like these are technical terms of the infrastructure that we've needed to build applications, but it's really they really miss the point of big data. These are a byproduct of these larger macro trends. They're not really big data in and of themselves. And so often when we see big data in the press, it's about Web 2.0 and social because they're developing a lot of the technology. A lot of the technology came from them. But these types of problems, these types of situations are present in every vertical, in every industry, right? So big data, the reason it's getting so much noise, not just in the tech press and community, but in the world generally, is because it really affects with a lot of all the industries, a lot of breadth and a lot of depth. So I don't expect you to be able to read all these specifics here, but pretty much in every sector and every vertical, there are people looking at using data to build smarter applications. Okay, so what's a data-driven application? Let's get down to brass tacks. So a data-driven application is really just the evolution of how we've been using data to make our applications better. So this isn't, again, this is not the first time that someone said, hey, we can make things better by looking at data. But we're just getting farther down on the evolution of how we can make applications better with data. So the first one is obvious, and I think everyone does this in some form today, which is, hey, if I take the data out of my application, if I export it, the data that's a byproduct of this application, I can do basic BI and reporting and figure out what's going on with my system, and then maybe make some business process changes or make some applications-based changes based on that data. This has been done for ages. And then, if 5, 10 years ago, 7 years ago, you started going to conferences and you see people talking about making apps better through data. So they're not just going to export data one way and look at it later. They're actively going to drive development decisions and import data into their application that they might have not done previously. So think about booking a flight, right? You used to go to one site, where are you coming from, where are you going to, what time are you traveling, sort by price, go. That was it. Now you can ask Kayak, where can I go for $500, right? There's the amount of data that's being used, whether it's the search process or the pricing models, which change minute by minute based on the price of fuel and competitive prices and how many seats are open. Data has just completely revolutionized the way people book travel. So you can see a lot of applications. Again, it's implementing the business process we had before, but it's using data to really make that application better. And so the last one is this new type of application building that I'm talking about. And it's not like the earlier types are going away. They're still valuable. This is just a new thing that I'm seeing, which is building apps around the data themselves, which the point of the application isn't primarily to implement a business process. The point of the application is to actually exploit the data, because that's where the value actually is for this, for this particular scenario. So let's go through these in turn just really quickly to give you a sense of what we're talking about. So this first one here, exporting an application data for BI, right? So we have an application. This is a very cartoon diagram of an application in the blue dotted box. We have some clients. There's an app server tier. There's some operational store that has the current state of the application. Maybe we periodically take snapshots of a subset of that data, load it in a historical store. Maybe we take some other documents from another part of the system, sales records or something from a different application, put them in the store. We can then do reporting. Okay, this application joined with this data. What does that tell us about our business? We can chart it, visualize it. I think everyone knows what's going on here. So something we've started to see in the last decade or so that's been more interesting is talking about making an application better through data, right? So now we've got the application in the analytical store. There's a bidirectional arrow here, right? So it's not just that we're taking application data, throwing it over the wall, and that's that. It's that actual data is flowing back from the analytical store back into the operational store. So you take an application, the data gets exported perhaps at a faster rate into the analytical store. We combine diverse data sets. We might build an enriched data set right, that has value from joining, some data that was purchased plus the application data plus another data set. And that data set might go back into the operational store, and to the user, the application just got smarter. It's like these magic tables, started showing up, and the developer could start exposing them. And you can think of, for example, implementing a better pricing model might work this way. So instead of just having a line in the database that says, oh, the flight from SFO to Atlanta is $700. Oh no, actually we're going to use a pretty sophisticated pricing model, and the results of that model will come back into the application. Make sense so far? All right, so finally, let's talk about this is really the more new model, which is building applications around the data, right? And so rather than have a world where applications are tightly coupled to one particular operational store, and then if you want to get data from different sources together and you have kind of a data integration project, you can actually build multiplication applications around the same data store, around a shared data store. So it's applications moving over the data instead of tightly coupling every application in its data. So this is a more data-centric approach, right? Because the data is the centerpiece, and multiple apps have to come to the data, not an application-centric approach where every single app is built around a particular data store. So again, what do we mean by this? What are the implications? This is a really cartoon diagram, and we'll get into a specific example. But the key differences here are, as I mentioned, multiple apps are built against a common store versus a bunch of discrete systems. We have multiple data models and schema, right? So what there's no one data model or one schema or one store for the application. We might have multiple types of data, right? So it's not, in the broader your spectrum, the more data you include in your system, the less likely you're going to have all your data be of one type. Right, so we may have raw data, semi-structured data, fully structured data, mutable data, all in the same system. And finally, we're going to use multiple tools to store, process, and query data, right? It's not just going to be one app tier, one relational database, we're done. There's going to be multiple tools at every single level in this system. And so one of the interesting things about this is that it's those differences end up giving you some pretty high-level benefits. And there's some complexities that we'll get to also. But the interesting benefits in the first, and this is often why people use this approach, is flexibility. So again, if you go back to big data and the 3 Vs, that's not often why people get started with this, right? You can actually do interesting things with a 10-node cluster, a 5-node cluster, a 20-node cluster, right? You don't have to be Google scale. And flexibility is one of the first things that draws people into this world. One of the things that also goes on here is that you're noticing that analytics and operational stores, the lines are kind of getting blurred here. So we call this converged analytics, right? So apps and analytics aren't these remote things that involve shipping data and different teams that don't talk to each other and completely different schemas that are not ever present. Maybe there's some ETL processing in by with a new team stuck in between there, right? Apps and analytics are really remote for most people these days. In this world, they're far more converged. And in some cases, you're even co-designing the application around the analytics that you want to do with it to feed back into the application, right? So when you think of a travel company implementing dynamic pricing, they're implementing that analytical engine that's creating the pricing model is as key to the application as any other piece of the application, right? They're thinking about this end to end. So we're sharing by default versus copying data around because we don't have tightly coupled apps and data. We're not copying data around. We share by default. And then finally, it's easier to improve the speed and sophistication in this approach, right? So the two attributes that are important when you're making an application better through data or building an application around data is how fast new information hits the system and how fast those insights are visible in the application or to the business, right? From the time you learn something, from the time the world generates a new piece of information, when does it show up in the dashboard? When does it show up in the application? When is it involved in a new decision? And the second is sophistication, right? Given that you can get this data in and quickly, how sophisticated are the analytics that you can do on it, right? Because it's not just enough to collect all the data. You want to do more and more powerful things with that data. So the previous talk was a great example of that, right? It's actually trying to dramatically increase the sophistication of what you could do to do new and interesting things. So one of the key challenges of this approach, and I started to hint at this, is that it really requires a full stack data modeling perspective, right? So you guys have probably heard of full stack developers, right? People who can, do front end, back end, data model, all in one. And if you think about it, that's happening increasingly, not just in terms of the application development tier, but it's also happening in the tier of data modeling, right? So this is a really high-level diagram of kind of the data modeling end-to-end in one of these applications. So we start with this platonic ideal of some information that we need to make an application better or build an application around, right? And then the developer, is going to build a conceptual or logical model around that ideal, right? Because we can think of numbers, for example, that are too big to fit in the system, or we can think of something, but that doesn't mean we have the right instruments to measure it to record the data, right? So, the developer is going to build a logical model of this. They'll then go model that in a physical model of a table, maybe a relational database schema, maybe a non-relational data model, right? But now we're starting to see the data model really reflect the type of system the data is stored in, right? If you've ever developed a large app on an RDBMS, you've seen how huge the tables can go, right? These 5 or 6 logical concepts just end up being, hundreds of tables. Of course, we might also include information not just from what the developer's worldview is, but existing information in this blue box here, right? With CSV, JSON, XML, raw text files, RDBMS. This is data generated by other people in other systems, according to their logical models of the world. And now that data is being encoded into your app, right? And so finally, we might do some analytics on it, and most analytics is done with dimensional models, which are the types of models you need to actually understand a business process. So they're denormalized, or they're way simpler than, say, an application logical model. And finally, we may archive the data, or we may delete the data, or never even store it in the first place, right? So this is the whole information lifecycle of application development, from the time we can think of something to the time it gets archived and deleted. And this is one of the interesting things about this type of application building, is you really have to think about this end to end, because we're using data throughout its whole life cycle. We're not just using a database to store the current value of something. We're actually building the app around the data and thinking about the data life cycle. So this is one of the key challenges of that approach. So let's make this more real. I'm going to talk about an application that's data-driven that we built. And we built this for support. So Cloudera, one of the things we do is support the whole Hadoop ecosystem of projects. And we have hundreds and hundreds of customers around the world. We've been in business for 6 years at this point. So offices all over the place, support customers all over the place, collecting lots of data from clusters all over the place. And our support has 2 modes. One is reactive, which is, if a new case comes up, we want to deliver a better, resolution to that problem faster. We have a proactive mode, right, where we want to prevent issues from happening in the first place, right? We want to prevent, learn from the support experience and make the products better so that they don't hit these same type of issues in the future. And we were already measuring support. So before this application, it wasn't like we weren't using data to think about support and to drive the process. So this is a small screenshot of a dashboard that gets updated minute by minute, and it has the time to first response by tickets, how important like a P1 versus a P2, how fast the statuses are getting updated on them. Are we meeting our contract compliance on 8x5 versus 24/7? How many open cases are there? What's the average time to resolution? What's the performance of handling those by the severity, right? Are the P1 tickets getting handled as fast as the P2s, and so on? So there's multiple screens of this, right? So the real question was, how do we make it easier to deliver a better answer faster, right? Because, again, we had the business process itself implemented. That wasn't the challenge, and that business process worked pretty well, and we collected data on it, and we used that data to prioritize the business. And the answer was to make it easy to quickly investigate diverse data sets. So let me go back a slide real fast. And why did we want to make it easy to quickly investigate diverse data sets? We're effectively trying to build software to help what the supporter themselves were doing, right? This is, if you think about what you have to do to solve one of these cases, you have to take data from a lot of different places that are very diverse, put it in one, kind of your own mental model to help diagnose issues by testing hypotheses and whatnot. And even just implementing the business process doesn't really help you do that, right? So the business process and what the core support person were doing were 2 discrete things, right? So how can we build an application to help, help the supporter do that core process? And what we came up with is called CSI, which if you watch TV, you'll understand why that's the name. And so this is a predictive customer support application. It's driven by the data itself. So this is a very high-level architecture. It's built on our platform, which is 100% Apache licensed open source, right? And so we take data from lots of places. So we have, the clusters collect data about themselves, and they bundle it up in zip files and ship it over to an SFTP server. And that has lots of data, logs, health data, configuration, metrics, you name it, it's in that bundle. That gets shipped periodically. People can upload it through a support ticket. We have a lot of public data from the JIRAs, the bugs, bug reports and feature requests, the Apache mailing lists, community forums. We have a bunch of private data, so our internal mailing lists, our internal bug tracker, our internal email, our internal JIRAs, right? And so we can take all that data that someone solving a case would have had to bring together manually. We can do that all in an automated fashion. So we can store it in Hadoop, we can in HBase, we can batch process it, we can use analytical SQL, running machine learning algorithms on it, right? And build an application around that data to help the supporter to kind of, let the machine help the supporter get their job done. So let's zoom in a little bit and see that, what the architecture of this application looks like. So we start, if you start on the left here with the clusters, they're going to upload these tarballs to an SFTP server, or they might get automatically uploaded from Salesforce. If you don't have internet connectivity from your cluster, you can attach it to Salesforce. Automatically gets SFTP'd over. We have a lot of email and web from both internal and private sources. There's a library of fetchers in the platform that were built to take all of this information, parse it, extract it, and then create HBase tables, figure out extract PDFs, use Apache Tika to extract all the text from the PDF and then put it in Cloud Era Search to index the content. We keep the tarballs in there for history, in the file system for historical reasons. We build a bunch of tables from this information. We collect raw logs. So, for example, all the download logs from our website through Apache Flume are going into the cluster, then getting turned into Parquet files that you can then use Impala to do latency SQL analytics on. And then the application, which is the center here, is built all around this. So the application is basically a Spring MVC application that runs on the same cluster. It's in Tomcat containers. It uses a project called Kite, which is a project formerly called the Cloud Era Development Kit that we open source for to make it easier for Java developers to build applications on Hadoop. And that can read and write data from HBase, those tables, but also the existing sources like HDFS, so it can fetch the tarballs out and deliver to me. You can dump them back in. It can update license keys. It can update customer record info. And it also, not only does it directly access with those data stores, it uses Impala and Cloud Era Search as services. So when it wants to give you free text search, it uses the built-in search service, uses the built-in query service, right? And this is all running on a 15-node cluster. Well, we just doubled it to 30 nodes. But this whole application is running modulo. The SFTP server and cluster and remote clusters is all running on one system. And so, and it's, this application is using multiple of those interfacing points, but there are other applications too. So we have Tableau hooked up to Impala, so we have product usage reports, download reports, ad hoc queries. If you want to figure out, hey, which customers are using which components and how frequently, they can query that through an easy-to-use UI. But the application here is really built on the fact that there are all these data sources being brought together with lots of different tools to query, process, and store them. So let's look at some specific examples. So the first is real-time log analysis. So one of the first things you often have to do when looking at a case is examining the logs, right? In our system, it's a distributed system, right? So there are logs everywhere. Every machine is running multiple services. Services are all generating their own logs, right? So you have logs with different timestamps from different machines. You have to correlate them, right? It's a very common thing that people do. Oh, and by the way, some of these logs are 60 gigabytes, right? You're not just going to SCP them over and pull them up in Emacs. That would take you ages. So the supporter logs on through a web UI, poof, they get the log search. The logs have already been ingested in the cluster. We're continuously pulling in and indexing them. And so you can do search with a timeline histogram rather than scroll through 60 gigabytes. So you can visually see if, in those little spikes about which particular time periods have all of the activity. It's figuring out that there's errors, warnings, and infos, which is some knowledge that we knew ahead of time that's common in all the logs, so we can highlight those. You can compare two logs side by side. It's basically all the things that people were doing individually. We just have it's just part of the application. You can just do that, right? So that's something that that was harder before because there wasn't an application that could access this type of data, right? We weren't going to shove 60 gigabyte log files into MySQL. So a second is just data exploration by search. So instead of, imagine instead of just looking at two logs to try to debug an issue, we're trying to figure out, what's going on in the first place. So you type in Kerberos because you're having a Kerberos issue. So it automatically generates a bunch of parameterized queries, so we can look at all these mailing lists indexed by date. This will pull up emails. This will pull up, embedded PDFs and documents. This will pull up the config files and the cluster bundles, internal emails, internal JIRAs, external JIRAs, support forums, you name it. It all gets pulled up for that one query. So if you have a particular issue, you just see all the information that you need about it. You don't go to every single store and say, oh, well, I got to go to the Apache archives and put it in here, and oh, maybe I'll use Google for this. Oh, that's on the private network, so I have to go use this JIRA for that. So instead of going to 5 or 6, 7 different places, you go to one place, it's all magically indexed, it's kept up to date. Again, you can do this as soon as you log in. Finally, a more interesting one we had recently was stack trace-based search, right? So stack traces occur everywhere throughout the platform. So it's one of the things that people often do is say, okay, well, what's going on here? What problem is this? So we have fuzzy matches for stack traces. You can say, oh, this particular stack trace matched this particular support case that we've already seen. Hey, what version of the cluster are they on? What version was that bug on? Voila, I know this is an issue. Right, the stack trace can be in multiple data types. Again, whether it's the JIRA or an email or a support forum, we don't care. It'll find all the stack traces. It actually indexes all the contents on stack traces, right? And that's something you can build when you can kind of program the platform directly like this. Like it's hard to do this in a BI tool. Imagine if you said, oh, I'm going to dump all my logs in a data warehouse and then provide a search tool. Well, it's not going to know what stack traces are. It's not going to know how to index them. It's not going to know all these data types. So this is the type of thing that you can build in a platform like this. And so I don't have a screen for it, but this is what we've shown so far is a lot of applications where, in a lot of kind of scenarios where the user is taking a lot of information from the cluster and visualizing it or exploring it. There are also ones where data goes back from the user into the application. So for example, the last support bundle says the person's running this version of the cluster, but I can see from the latest logs they're running a newer version. I can update that. Poof, it goes all the way back into Salesforce, right? So there's a two-way flow between what the data that's being consumed and then being back produced. So another one, for example, is, hey, I want to launch a cluster with this exact same configuration on OpenStack over here. Automatically go fire that up for me, load all this information, write it out. So where is all this going? So, so going back to the kind of whole CSI theme, and I think this is a good one, is that really we're talking about helping people do what people are good at and let computers do what computers are good at, right? So computers are handling more and more of the intent for us, right? So rather than just serving up logs, they can index for them. Rather than just indexing them, they can actually know about the contents, right? And so, and maybe they'll find all the cat photos, in our logs. But they're getting smarter and smarter, right? And so one of the things, we were talking about building is when you log in with a particular case, it already starts generating hypotheses around what the issue is. Like, oh, it's this stack trace. What build are they using? Is this that build? Oh, blah, blah, blah. They should upgrade, right? You can imagine a lot of this stuff, you can actually start immediately generating pretty decent recommendations. And you can also start getting more proactive, right? Like this intelligence can actually go back into the software and saying like, oh, you need to update because you're using these combinations of components, which has this issue, and you should update to this version. Right, so we can take this intelligence and start feeding it back into the products and also build something that's more useful. So if you've ever watched CSI and you just put in some DNA and some text and some photos from the crime scene and voila, that's the killer. The same thing, like more and more, that's the experience we want to go after. There's more and more rich data types and more rich analytics. So the human can just focus on what the human wants to do in that process. So anyway, that's how we've been using our software to build a data-driven application on our open source platform. And so one of the things I just want to leave you with is to think not just about how you can use data to make your existing applications better, but also what kind of new types of applications you could build around the data you have. Thank you.